All right, so a lot of this stuff we've already done before. So we're going to start by looking at the things that we already know, and then we're going to apply them to some other things a little bit. All right, so if I write something like this, that means 2 to 7, right? There are 2 parts over here, 7 parts over here. If I said 3 to 12, I can simplify this ratio, right? Right, 1 to 4. So think of it like a fraction. You can think of 2 to 7 as a fraction as well. Same with this. You can think of it as 3/12. So we can simplify this in the same way that we would simplify a fraction. All right, so always try and simplify your ratios. Otherwise your answer is going to be incomplete. Okay, so you want to write all your ratios in a simple form. So let's have a look at some shapes. So if I was doing, so we've already covered similar shapes and ratios. Remember, if I say that that's 2 and that's 5, and then this is 5 and this is x.
Wow.
So what I'm going to do is set up ratios, right? I'm going to set up my fractions. These are the 2 sides that match, right? 2 and 5. And then these are also the 2 sides that match 5 and x. When I have 2 sets of fractions like this, what do? Cross multiply. So then if I cross multiply, I get 2x equals 25. And then x is 12.5. All right, so that would make this length 12.5. All right, so always set up. Hi, no, you don't need anyone today. I'm sorry, it's not happening. But thank you. So there's another way that I could have set this up. And I'm going to show you why it still works. I could say small to big. 2 to 5 equals small to big. See how this is different to this? Well, these 2 5s are in the opposite directions. That is so unhelpful. All right, let me just show you. If I made this, actually, no, let's leave that as 5. Let's leave that as 5. I'm going to make this 7 just for argument's sake. So this would then be, I'm just going to show you how that works. If I've got 2 5s, it makes it harder to see. So this is, actually, let me erase this so I've got some more room. All right, so 2 over 7, right? These are the matching bits, equals 5 over x, and then we would cross multiply. So 2x is 35, so x is 17.5. All right, so this is then 17.5. So if I did it like this, I'm going to set it up a bit differently. So what I can do, let me change color so I can do it differently. So then what I might do is say this side, so this is small to big, equals small to big. When I cross multiply, see how the 5 and 7 have switched? But it doesn't matter because I'm cross multiplying anyway. I'm still going to multiply the 2 and the x, and I'm still going to multiply the 7 and the 5. So I still end up with the same answer. It does not matter which way you do it, whether you do small matching sides over matching sides or small to big, small to big. As long as you're consistent, it doesn't matter which way around you do it. So whenever you have, so if we have something like, should I save this? I should. All right, let me give you another example without diagrams this time. We're just going to give you numbers. All right, so what if I said that 2 to 5 equals 13 to x? Before I said that ratios can be written as fractions, so I'm just going to rewrite them as fractions. So 2 over 5 equals 13 over x. All right, so then I have 2x equals 65. So I'm just cross multiplying, which means x is 32.5. All right, so when they're written like this, just rewrite them as fractions and cross multiply as normal. All right, what if I...
So you see how the ratio says 2 to 5?
Yeah.
What if you divided both of them by, not the one on the right, but then if you divide 2 to 5 by 2, so it would be 1 to 2.5. So you multiply that by 13, that would equal
That is something called a unit ratio. Absolutely. So if you want to, so let's just do what Neil one said because he's right. That is another way to work this out. Whoops, that's not an X. All right, so what he's saying is that I could divide this by 2. So this is 1 to 2.5, and then I'm going to halve this. So this is also 6.5 to half of X. Whoops. Or 0.5x. I suppose we should stick to. So you can do things like that. I mean, it's going to be, it depends how else, what other information you have. But then in this case, I mean, sometimes you can sort of see for here, you multiply by 6.5. So for here, you also need to multiply by 6.5. You can do it like that. I find that that's slightly annoying because you've got decimals and stuff, but if they're whole numbers, it would work easy. I like to teach this method, but this would also work. All right. I am going to give you a worded version of this. So when we get worded versions of ratio questions, that's when it becomes a little bit trickier. Timothy, focus, buddy. All right. So what if I have something like, I did.
Wow. That was really cool.
It's very, yeah, it really was okay.
Yeah, that was.
It will be.
I was watching my revision, right? And you're like, Timothy. And my mom's watching and
That would be very funny to hear your own name at home when you're watching it back. Timothy, are you paying attention? That will be hilarious when you watch this tonight. All right. What? Oh, it's a new MacBook Air. Okay, so let's say that I'm making goo. All right, if I'm making goo, I'm going to use 2 parts water. Goo, I'm going to make goo. And I'm using 7 parts. Oh, that's not going to work at all. I should have done it backwards. Yeah.
And you have to do an activator. Yeah, activator.
Oh, stop. Oops. Nice, that contact. Yeah, that's how you make oobleck. Yeah. Non-Newtonian fluid. All right. Shh. Focus. Okay, so this is how you make, oobleck or a non-Newtonian fluid, which is kind of fun. I can't remember the best ratio of it, but I'm making it up. Okay, if I have, let's say that I have 17 parts water, how much cornstarch should I use? Well, let's think about it. You want to set this up as an equation. So I've got 7 parts water to 2 parts cornstarch. Now I know I have 17 parts water and my cornstarch is my unknown, right? So I'm just going to set them up as fractions and I'm going to multiply. So then I get 7x equals 34, 4.875. So a bit less than 5 cups of cornstarch is what I should use. So when you have sentences, try and turn them into ratios, then set them up as fractions and cross multiply. All right, there's one more thing we need to do. Careful. All right, so there's one more thing we want to cover, and that is, okay, I'm going to give out 20,000 rupees to you guys.
Yeah.
Okay. So, Hayan, you get 2 parts.
Yeah.
No, I can never spell your name right. You can have 3 parts. Josh, you can have 5 parts. And Amin, you can have 1 part.
Yeah,
All right.
for real.
That's all right. I'm biased towards my own people. All right. So what I need to do is figure out how to split this much money between these people. How many parts am I splitting this into? 11. Okay, so this is 2 plus 3 is 5, 10, 11. So,
You can give me one.
so that means 20,000 needs to be divided by 11. Okay, 1818. All right, we're going to leave it like that, and then I'll keep the leftovers. All right. So 1818 rupees. So what I need to do is say, so I've got, hang on. Oh gosh, you both start with AH. That's so annoying. You can be HC. 2, Samriti. 2, Josh. 2, Hamin. All right. So what I'm going to say is Hamin gets 1818, right? That's what he gets. But Han's getting twice as much. So how much is she getting?
36, 36.
She's getting 36, 36. How much is Samriti getting? 3 times that?
8 plus 16, 14, 14, 24, 24.
5, 4, 5, 4. How much is Josh getting? What?
909.
Wow.
And Hamin gets 1818. So you see what we've done. This is the important part. All right. So this bit here is the important part. When you're splitting something into multiple parts, you need to add up all the parts. So 2 plus 3 plus 5 plus 1 is 11. And there are 11 parts altogether. So I divide it into 11, and this gives me 1 part. So once I've got once I've got 1 part, I can distribute that for however many parts each person gets. Make sense? All right, that'll do.
I absolutely.
This is such a good way to.
Like and subscribe, Samriti.
Okay. Guys, don't forget to like and subscribe. New videos every
Well, I have a
2
question.
days.